who is a data scientist? And this comes up a lot because it's a confusing term, and I have some opinions about this. So, who is a data scientist? Or who is data science? How about that? That's easier to write. Who is data science? And in general, I would call it more of a behavior than a job role. And what I mean by that is we have behavior and then we have a job. And if you look at the difference with a job, some of the things that happen are that you have a fixed level of things that you have to do, right? So you have a task that you're supposed to perform, but in a behavior, you have a capability. And what this means is that you can apply that behavior to many different things. Also with a job, a lot of times you can say that this is not my responsibility, right? So you can delegate to other people, which may or may not be good. But with a behavior, you have the ability to solve a problem using your skills. And also, you could think about this as critical thinking is another way to think about this behavior versus obedience. And a lot of why people can be good at a job or not is they do what they're told, which there are some cases where it's good to do what you're told, but there are many cases where it's not good to do what you're told. And this is where the critical thinking comes in is do you know how to make your own choices based on facts, right? So, and in fact, I have a very good example of this. So if you look at, for example, let's actually go through here. This is one of the, I think, most important things to know about critical thinking is that with critical thinking, you don't listen to what people say, you listen to what the data says. And so a tremendously good example of this was in the USA, for example. There was actually, let's compare USA and China. If we look at the difference here, that with COVID-19, we saw data scientists. In fact, I saw this, that there was data that showed this, right? We see this plot, and we look at this, and we said, that's interesting. This looks like an exponential curve, and then you look at other countries, and they also started to see exponential curve. But the difference between China and the U.S. is that there was critical thinking here, right? And that science was applied to the problem, and there was a corrective measure that took place with COVID-19. If you look at the U.S., we at this inflection point, we didn't use critical thinking. Instead, we said that there's no problem, right? And as a result, now the U.S. has, I think, leads the world in relative deaths via population, right? And so this, I can't think of a better example. Life or death situation is when you're presented with data, you can either guess or even listen to what somebody says, or you look at the data and you make your own decisions. And this is really the essence of data science is dig into the details, find the results of the data, and then see what you can do to apply those critical thinking skills. And how does this manifest itself? Well, one of the ways that it manifests itself is in the data science workflow. So let's just recap that again in terms of the data science workflow. One thing that is the start of a data science workflow is the ingestion phase. And with ingestion, this is the collection of the data. And there are some estimates that, in fact, this could be, at least in the real world, around 80% of the time involved in data science. And so I guess, again, if we look back at the COVID-19 problem, it's non-trivial, right? To how do you collect who has the virus, who doesn't have the virus? This is substantial amount of work, but it's worth noting that this is part of the data science workflow. Is, do I have any data, right? Can I collect this data? The next phase, where this really applies a lot in terms of business analytics and maybe statistics as well, is can I actually go through and explore what's happening, and can I look at the relationships? And in fact, again, as I mentioned before, in the USA, the COVID-19, in fact, you don't even need data science. In fact, EDA would have solved the problem. The EDA is just a simple scatter plot, and the scatter plot will show the mathematical nature of the data, right? It'll show the distribution, and in fact, the distribution was exponential, right? So this gives you that initial intuition. Okay, what am I dealing with? Am I dealing with time series data? Is it categorical data? Is it, what kind of data set am I dealing with? So that's phase 2. So this is step 1. This is phase 2. Phase 3 would involve modeling. And modeling is interesting because, in a way, it's a one way to think about it would be you do a prediction. So you could go through and you could say that, for example, in a time series problem like COVID, or maybe financial data or stock prices, you could do a time series forecast, but there's also other kinds of forecasts, right? So you could go through and you could do a categorical prediction. So you could say this is a dog or this is a cat, or you could do, we talked about that time series. And there's also computer vision, right? You can go through and apply the modeling to that. There's lots of different kinds of modeling, but in a way, the model is only so interesting because if people don't listen to what you're saying, then it doesn't matter. And again, this goes back to the COVID-19 situation, and why data science is one of the funnest things to study, is that you actually could do all this, right? You could be an exceptional data scientist. You could have gone through and done the ingestion, collected the data, done the exploratory data analysis, created a model that correctly predicted all these things. But if you don't convince the people in charge of what the right approach is, then what will happen is that everything that you did, it will be a failure, right? And so the conclusion is a very important thing to consider in a data science workflow. Is if you can't convince the people in charge about what you're trying to convince them to, then actually none of this mattered. So you're just wasting your time. So this is a very tricky problem, and this is why when I'm talking about a report, it is very important to be very thoughtful about how you use critical thinking and writing skills to make your case. And so let's actually talk about that next. So let's talk about this conclusion phase. So in a report that you're trying to convince a business professional, so we'll go to this conclusion. What is it that is important? Well, there's a couple things that are very important here. Is that a lot of executives or leaders, unfortunately in the United States, even sometimes they don't even read books, right? And that's unfortunate because they have a short attention span. And you may need to start with the most powerful statement, right? Is can I describe the problem, right? In a conclusion. For example, you could say, we need to create a new product because of this new product has the potential to make $4 billion, right? So maybe that's the describe the opportunity or the problem. Also, you then have to say how you're going to, so we'll say describe the problem or opportunity. And you also have to say, how am I going to do it? So how can I do this? And be very specific with the steps. So, we need to create a new product because it'll give our company $4 billion. And how? So we are going to do product market fit analysis. We'll say PM fit analysis. We can partner with a new company. You go through and you say the steps essentially. So we have A, B, C, and then finally at the very bottom is would be your recommendation, right? And you recommend the solution, and it's important here as well that the length of this, when you're writing this in a business situation, is at most 2 pages. At most, even one could be better. And again, unfortunately, part of the reason for this is that a lot of people in business are not critical thinkers, or they're there because of power or maybe some other reason. In some cases, it's there for merit, and that's always a good thing. But a lot of times they're not, and so you have to take this personality type and really convince them very quickly. Here's a problem. Here's how you do it. Here's a recommendation. And in a way, if you put equations, onto a f of x, or you start putting things, mathematical notation onto a conclusion, they might just throw it away, right? It would be like, in the case of the United States, giving the president a book, he would just throw it away, right? I don't want to see this. This is so. It's very important to think about who is your audience and be very careful about describing the problem and how you fit the problem, and then your very specific recommendation. Right. So this is really in a way the most important part of data science, and it doesn't necessarily mean you wrote any code at all. And we've discussed this, and we'll go back into this again. And so if you have this mindset that really data science is about critical thinking, collecting data, coming up with some kind of a solution, and then presenting those ideas, this is an important way to think about the world. So let's start to maybe recap this a little bit and think about how you could approach this in the real world. So what I would recommend when you're building a data science project is to have this formula where you apply this potentially in a Colab notebook. So if we started and let's maybe start to build this step by step. So I would say I would go to GitHub, and let's say I was preparing as a business intelligence professional or a data science professional. I was going to prepare a report. I would probably start with a repo, and we can just say, business intelligence report, for example, and say this is my information for a critical thinking exercise. Add a README here. That's probably good enough. And you don't even necessarily need to write a lot of code to get started with this, but I think a GitHub README can be helpful, or whatever source control system you're familiar with. And inside of here, you could just put a little bit of information like the problem that you're facing. So, this is an analysis analysis of a problem, right? And then you go through here and you put a little bit of information, and then say maybe at the very end conclusion, and then you could have a link to a notebook right here. This is the report, right? And you just have a couple sections. So actually, maybe even I just say analysis here, notebook, and then conclusion. And then I would then go through and create this notebook, which we'll recap again here. So got this basic structure here. So someone in your company or the business leader, you're trying to convince them of your solution. Then I'll go through and create a notebook to collect some of the ideas. And I do think that this Colab notebook approach or Jupyter notebook approach, it is one of the better ideas for doing data science. And the reason I like it is because you can create this nice structure here, where you can use this formula like a scaffolding every time you work on a project. Say ingest here. You can say EDA, and conclusion. And in particular, this structure, it works very well for being the technical report. And then if I say file and save copy in GitHub, we have this technical report. And we'll go to this new GitHub repo here and say business report. Here we go. Commit it. And then when you're presenting this report to someone, a lot of times the business leader will not actually look at this notebook. So you can just put a link to this and just say, technical report or something like this, and maybe they don't read it, but the person on their team will read it, and so it's your job really to put the conclusion together in whatever you're doing, a document or markdown or whatever that has very specifically your recommendation. So this is the part that I think is missing in most data science that I've seen, is that you could put in a link here that says, my recommendation is ... And then it could be very short. It could be just a paragraph, like, and I'll just put that one paragraph. So you've really, actually, that will show up. We'll do this. One paragraph like this. So this is a pretty small amount of data, and under the analysis, right, you could put more information, 1 or 2 pages. But what's important about this is if somebody's very busy, they can look at it and then say, oh, okay, you made this recommendation, great, and either they reject it or they accept it. But what I see a lot that causes problems is that if someone looks at a technical report, in some cases even, unfortunately, people in power that don't have the technical skills, they may see the code and get angry. They get angry that you're showing them math, which is unfortunate. But a lot of times, if they see an equation or they see something like this, they'll get upset. And so, still, you can have all this. You can have mathematical notation and graphs and R squared and metrics and all these different statistics in here, but keep it in a notebook, and even keep it hidden like this, collapsed, but more focus on the persuasion, right, inside of this report is think about the fact that someone could be very busy and you need to really quickly come up with a way to impress them and say, look, this is the problem. Here's all the analysis. You can look at this later, and people on your team can look at the analysis. I have all of this, and it's very, rigid, but this is what we need to do. And I think this is the best way to get a result in a company. And a lot of times when I've worked in companies where they're doing data science, business analytics, that this approach is the one that's effective. But if you go to a business professional and you start to show them charts and graphs, a lot of times it goes poorly because they don't want to listen to it. Right, so this is, I think, a very important skill to think about when you're building your final report. So let's now maybe recap. Now we know that this is the structure, but how would I also start to build out my technical report? Because it could be that the business professional you're working with says, "Oh yeah, this sounds good," and then they say, "Hey, I would like the other people on my team to investigate." So you still need to have all the technical details inside of the report, so you should also do that. So let's now go through and see if we can use some like high level tools that in fact use very little code to do some kind of explorations on code. So as I mentioned before, one of the things that's fun actually about data science is that you don't necessarily need to write any code. And this is what I wanted to cover a little bit today, is that this is called no code, low code. And this is an emerging trend. It's obviously great to know Python. I like Python, but there's also an expression called YAGNI. And this is one of my favorite expressions, and it stands for you ain't gonna need it. and a lot of times, as a business analytics professional, you don't necessarily need to do programming. You can start with some ideas and solve those ideas by using low code and no code solutions. And so let me summarize some of these no code, low code solutions. So some of them could involve the cloud platforms. I think in a way, the cloud is a very interesting place to start with these high level tools, because they're giant companies, right? We have Apple, which is I would say cloud and tech giants. We'll say cloud vendor and tech giant and tech giants. And in terms of Apple, and I'll briefly talk about this, they have low code machine learning tools. And this would be computer vision and ML. We also have GCP, which has these low code, no code tools, including computer vision, Automl. We also have AWS, which can do low code, no code. There's a ton of things on AWS. In fact, they have, and maybe we'll go through all of these different capabilities again to recap them. Is they have tabular data, which is a very good format for business analytics. They also have AI APIs, right? So they have computer vision and NLP APIs. And then there's also, I guess we'll put it right here, there's also Azure. And Azure has a ton of APIs as well. They have computer vision, and they also have AutoML and lots of different capabilities here. So as a business analytics, business intelligence, data science type person, this might be one of the first places to stop if you want to do the EDA phase. So we can think about this. What would you do in here? I would say this could solve EDA and modeling and ingestion. In fact, all three can actually be tackled inside of these cloud platforms and tech giants. You can leverage what they're doing to solve problems. And so in a way, you could potentially not do any code at all and come up with some very good analysis and then write that up when you're solving a problem. So let's take a maybe step by step. Let me show you some of the things that you can do. And even I guess what I could do is put inside of here at the very beginning, I can put a section called resources. Let's do this. We'll go through here, and we'll call this resources. So business intelligence, data science resources for low code, no code. So step one. So I guess we can use our notebook to take notes here. So step one would be, let's look at Apple here. Maybe I'll just do a section here that says Apple. So what do they have that's interesting? I think one of the things that's very interesting about Apple is they have something called Create ML, and Create ML allows you to create machine learning models with low code or almost no code. And here's a picture of this, is that they have a system that will accept images and allow you to create a model. And so how does this work? This is really the feedback loop here, as you ingest the data, like I talked about, you do the training, and you do an evaluation. So it's the same type of a workflow. And so let me just put a note here in this notebook. We can say create ML. To say create ML, and put a link here like this. Okay, so we got create ML in there, and what is it? Why do we care about create ML, especially if you into a low code, no code solution? Well, let's look at this, creating an image classifier model. What happens with an image classifier, we know high level, you can train a classifier to give it many examples, like an elephant, a giraffe, whatever, and tell it to recognize the differences between those images. So what's nice about this approach here is they only need about 10 images, but a little bit more could be helpful per category. You put your data into a folder, just like this, and then once you've collected that data, and maybe even I can take a picture of this, and we'll say copy image address. Notice that I can, in my report, which is kind of neat, is I can click this link. Actually click this, and I can actually make this into a picture that if I was doing research for a company, I think it's like this. Actually, let me see. I thought it was this. There was a way to do the link of a picture here, but I think it's something like this, maybe. Is that how you do it? Or is it like this? If for some reason I can't figure out I'll just do this. Let's see, markdown link, markdown image link. What is it again? You do this. I'm so lazy I can't even put this in here. So I'll just do this, and then I will put in the path to that image here, which is this, I believe. Does that work? Anyway, I'll fix that later. we'll just keep this link in here for now. But basically, the core idea is that you want to organize your testing data into a directory structure, put it into a project like this, image classification, choose the options for your new project, and then go through and drag that into this GUI, right? So again, no code at all. There's no code that you're writing. You're just creating your images into a directory, dropping in here. And then you have, in this particular situation, the ability to add noise, blur, cropping, etc. You then have some testing data. So this, after you train it, you want to make sure that it works, right? So you put the testing data inside. After you're done with this, you can, again, as I mentioned, add some parameters to maybe enhance the data. A lot of times when you're doing a computer vision problem, you don't have enough data, so you can select augmentation, which will allow you to get more data because you can flip the image and rotate it and do things like that. Once you train it, it'll go through and give you a result. So we don't have time to get into all the details here. This is something I would recommend trying on your own. But the core idea here is that you can use a low-code, no-code tool and come up with something that helps you do your business intelligence report. So maybe it's that you want to analyze competitors' product images, and you want to train a classifier to detect anytime you see a competing product. And so you can go to a store and you train a classifier, and you can take pictures of the products, and then you see, this is a competitor's product is in the store. So we need to investigate what this competitor's product is, as just one example. So we'll just go through this step by step. So we got Apple here. That was one. Who's next here? We got. Let's just do this 4 links here, and then we'll add another company. And I think we had GCP. Okay, so let's go to GCP next here. So under GCP / Google, there's a lot of powerful stuff that you can use. And let's start here with GCP Console. And I think probably Automl might be one of the more interesting ones too. There's 2 forms of Automl that I think business intelligence people would want to know about. The first one would be Automl Table or Automl Vision. And Automl Vision, here's an example of it. The way it works is that you upload data into their cloud platform. Make this a little bit better. In this case, I would say new data set, and you decide, just like the Apple example, I want to predict a particular label, like one label, or I want to do multi-label classification, predict all the correct labels, or I want to do object detection. Once you let's just select that, for example, all you need to do is either upload the images or select a CSV file that points to those images that you put in cloud storage. So you just, again, don't have to write any code, just drop it into the cloud storage, say what the name of that file is. It's a cat, it's a dog, whatever the label is that you want to detect. Maybe make this a little bit bigger. Once you do that, you go, your data set, it will go back here, it will show up, it'll be visualized, and you can look through and filter and see the different pieces of data and analyze them and prepare your report. And then you click on this train button, and again, no code, low code, just click train model, it'll train it, and then it'll come up with a result that looks like this, where you will get a bunch of metrics that show you, even if you're not an expert in machine learning, what's happening. And this is fairly easy to understand. This confusion matrix is that it shows you when it was correct. If it's in blue, that's its accuracy. And then these other sections are when it was misclassified, right? And again, I can even look at each of these and it will visually show me when it was correct, the true positive, when it was false negative. So it should have predicted it, but it didn't. And then false positives, right? So, and then later, if I wanted to be also low code, no code, I could export this model and make it run on a mobile device, right? So maybe I'll just put a link to that here. And we'll say Automl Vision. There we go. We got a link to this. What else can you do with the GCP platform that's low code, no code? I've done this with MBA students. Automl Tables is another one that's pretty interesting. So you can take tabular data, which is something you'll get all the time as a business professional. And with tabular data, you can go through and upload it as well. So I'll just show you real quick how you would upload it. So we say new data set. We create a new data set. You could either import it from the Google BigQuery system, which I'll show you briefly, which allows you to do ad hoc queries on data inside of a console. You can upload it from a CSV file in cloud storage, or just take a file off your computer, upload it. Now, what does it do? Well, this is, I think, the future of machine learning, and why I think it is okay to not be an expert in software engineering. If we look at a data set like this, you ingest this data, and it shows you all of the key things that you would need. If I go to, let's go back to, here we go. If I go through here, it shows me all of the attributes that are in my data set. So all the columns in a spreadsheet, it will infer the type correctly. So AutoML will go through here and find out the numerical types, the categorical types, the text types. It will even show through, basically descriptive statistics, like how many values are unique, etc. And also, if I click here, I think I can scroll over a little bit, that it will also show you the correlation, right? So this is something that is called feature engineering. I can see that certain types have higher correlation with the target that I'm going to try to predict. So really the only thing I need to do is maybe look at this to make sure that everything is correct in terms of the data types, and then also select what I want to predict. I want to predict whether someone will be married or not, or I want to predict what their income level is, or whatever I'm trying to predict. Once I predict this, then I go to evaluation and I look at the metrics here, and I can see exactly the accuracy. So in this case, this is 83% accuracy, or area under the curve for precision recall curve. And then I can also go down as well, look at the confusion matrix. What was it good at predicting? So it's pretty good at predicting whether you won't make a lot of money. It's less good. It's okay, but it's less good at predicting whether you'll be greater than 50,000. But we can see here the feature importance, right? So this is, again, for a business professional. Maybe what I do here is I just do this. I take a picture of this. Actually, does it let me download this? It gives me the whole, well, actually, yeah, that's pretty interesting. I can just download this, and then I can put this into my report. So let's go through here, and in fact, again, I don't even have to write any code. I just say add file, upload some of my code here, feature importance. Let's put this inside of here. Commit this change. And now I can put this link. And if you click on this, you can see the different features. And I, even if I wanted to, could cheat a little bit and write a little bit of code. And so I could, ingestion here, I could say import pandas as PD, and say df is equal to pd.read CSV and put that path in, and then say df.head, I don't know, 20, or I don't know how many rows there are. And so I've actually got a little bit of raw data that I could look at, right, in my report. So it looks a little bit technical. So I have some, and also, by the way, if I go back to this, this is what I was going to show you earlier, is if I do a screen cap, I could actually do this. I could put this into my report without writing any code. Just take a screen capture, go to this project here, create an issue, and say new issue, images, and then I like to just drag in a screenshot like this, and it creates the URL for me. That's what I was missing. I'm so lazy that I don't want to do any work. That's why I actually like no code, low code, and here we go. And I go to this, and then maybe I put this under my exploratory data analysis picture, right? Here we go. We got some exploratory data analysis, and then I say return, shift return, and now we actually have a nice graph, and I didn't even make it, right? Somebody else made the graph for me, and I have a good feature analysis, and I could say here, these are some important features. You can see this data in this raw data in the ingest section, right? So I'm kind of building up this portfolio. And then again, if I want to save this and I want to let other people see this, I can just go again to save a copy in GitHub, go back to my report here, and put it into business report and check it in. And also, if I want to give you a copy to all this, you can get a copy as well. So I'll go through here and put this into chat as well, and just throw this in. There we go. Okay, so now that actually we should do this whole repo. Do this. So now that I've got this whole report created, again, all the technical details are kind of hidden in here, and maybe later I'll tease these out. But let's keep moving. So this is great, right? I can do this with GCP AutoML, but what else can I do, and what are some other companies that I can use their tools? Well, if we look back here, what do we have next? We have AWS. Okay, let's go to AWS next here. Let's take some of their skills. So AWS has a lot of stuff that you can use, and it's amazing actually how many services they have. And one of the first ones that we can log into here with is potentially the, let's start with NLP. So with NLP, the main service that you can use is this Comprehend service. And if I click on Launch Comprehend, you can see we'll be able to do some NLP, which I'll do in a second. But I also wanted to show a different Comprehend. There's two forms of AWS Comprehend. There's text-based, and there's also a Comprehend Medical. So depending on what problem you're solving, you could launch a different one. The reason I wanted to show this is, let's say you're working for a medical company. You could actually just paste a medical record for somebody in your company. Again, right, not writing any code. Here's one. This is their medical record, like this. And we say analyze. And inside of this, you can see all of the different text. So visually now, we've created a report, and I can take this report and I can give it to the doctor or to maybe the CFO of the company and say, we have some really important facts here that we need to analyze. And what I could do is maybe minimize this and take a picture, for example, of this particular output. Let's see here. What's a good one to show? Let's take this. Here's a good chart, and I could again take a screenshot and maybe this is just a good screenshot. Okay, good. I've got the screenshot, and we'll go again back to this repo. Go to my issue here. Go to images and put another one inside. So we'll take this new screenshot and we'll throw that in. Great. So now we have some details that we can put into our technical report. So we have another detail here. Let's go through here. We'll say maybe another section, and we'll say this is a medical record. Paste that in. Now we've got another chart, right? But let's go back to the regular comprehend real quick, and again, one of the main ways to probably do this would be to, let's say I was going to do research on a competitor, right? This is a very business-centric approach. So I would probably start with Wikipedia is a good source for doing research. And let's say it was Nike, right? I want to know what, let's say I'm a shoe manufacturer, and I want to see what I can learn very quickly so I can give this report to somebody in my company. So I'm going to take maybe the first section here, and I'm going to copy it, and then I will go to this input text here and just paste it in, just like this. And I'm going to say analyze the text, and what it will show me is all of the entities inside, but I also can go through and find key phrases, right? And I also could find syntax or sentiment, and we can see that in fact there may be one thing that I would want to look at is the sentiment, and in fact what could be important here would be that if it's a journal article, it should probably be neutral, but we see that this is actually a little bit positive, which is interesting. So I could then maybe look further and say, I want to do some research. And what if I said, I look for news about Nike. So I go to, let's say, Google News or something like this, and I type in Nike. So let's look at Nike here. And we find some news about Nike, and I want to see what my competitor is doing, and I want to see if people are writing good things about them or bad things. And here we go. I'll copy this, and I go back to this business analytics section or comprehend, analyze this, and I look at the sentiment, and I see that also this is neutral. So it looks like a lot of people are writing neutral articles about it, but maybe I can find another article. Here's another one. Let's just analyze a few, and I can do this very quickly because I'm not writing code. I can do this very quickly, right? I just cut and paste, and I just do some very quick research. Let's see here. Yeah, this looks like a good one to analyze. Sentiment here, same, pretty neutral. So it looks like maybe this competitor, people aren't writing very, very positive or very, very negative. They're more of a neutral, and maybe even I just go like this and I say I did a little bit of analysis, and it looks like a lot of content around Nike is pretty neutral, right? So that's my initial findings for using these off-the-shelf NLP tools. So again, go through here. Let's add another section. And we'll say, Nike research, and paste this in. All right. But what else can you do with the AWS? Well, there's a lot of other stuff we can do with AWS. One thing you can do is they also have they have some computer vision tools, and one of them that's pretty interesting is recognition. And with recognition, you can actually do lots of different computer vision tasks without needing to write any code at all. And here's one that could be pretty useful for, let's say we're still analyzing Nike, is if I go to text and images here, what I could do is I could go back to this article and I could just see, again, maybe I want to start looking at what kind of things my competitor is putting into their product. Well, I can go here and I can save a picture of this. I can go to recognition. I can upload it, put it into this section, and here we go. So I didn't know this. I couldn't read that. So now I know that this in fact has the word fees. So maybe that's a new feature. So maybe this is something that we should start looking into, right? And in fact, I could grab this if I wanted to, or this is probably the English version. It's probably easy enough. And maybe even I take a picture of the whole thing. So I could just take a picture of this and just say, okay, look, we're detecting that Nike has something called fees. Maybe we need to do a little more research on Nike to see if we can figure out what they're up to. So let's add some more. We'll say computer vision research for Nike. Here we go. And again, take a picture of this. And I think it was this screenshot here. Let's double check. Actually, I can put it into the images. That's a better way to do it. Comments. Ooh, that's too big. It doesn't like that picture. It's too big. So I'll just make it a little bit smaller. We'll just do this. Let's make it smaller. And go back to images here. And there we go. Comment, put this in. There we go. Got some computer vision research for Nike. Refresh this. This Colab notebook is struggling for some reason. Maybe what I'll do is go back here and not sure why this thing has got problems. Exit. Okay, so here's my computer vision research and paste this in. All right. So we can do like text recognition, label recognition, scene detection, all kinds of stuff. Like also, I guess I could take that same picture and go through here and do research and see information about it. And again, maybe this is all I need to do is just take a picture like this. It says, okay, here's what I found out. They're making footwear. It's a running shoe. It's a sneaker, and it's got the word fees in it, right? Or flies or something like that. And we go through here and do that. So the other thing though that you can do with I think that's what I was screwing up is you put it into. I think the problem is that I want to put this into the images section first, or else it gets too overloaded. So you let GitHub do the hosting like this. Okay. That's probably good enough. I have enough of these pictures for my research. There we go. So now we have additional information. So what else can AWS do? Well, another thing that AWS can do is it also has that tabular data science, right? So we can go through here and we can go to a service called machine learning. And this machine learning service also allows you to ingest tabular data. And the way this works is you put the data into Amazon first, and then you tell it to do an analysis. And so if I go to Amazon Machine Learning and I say create new, data source and model, paste this in, here's a location to the data, and I call this banking data, and I verify it. It does that same process. It goes through and it looks at this data, and then if I say yes for the column names in the first line, it will allow me to accept this data. And then if I go to next, it'll ask me to, what do I want to predict, right? Which is the whole point of putting it in here. And if I go to the last section here, there's a target value, which is I want to predict whether they deposit money in my bank or don't. This is banking customer data. If I click yes and I click continue, it'll prompt me to make some choices. I just keep clicking continue, and it'll say basically generate a machine learning model that does a prediction whether these customers will deposit money or not deposit money. I click review, and it will go through and it will train the model. That's it. So I just upload some data, select the columns, select the thing I want to predict, and it'll train the model. And so what does it look like at the end is if I go to an end result, is that it will show me the metric, just like with Google. And I also could look at the evaluation results and dig in deeper. So we can see that this is area under the curve, and I can explore the performance and do trade-offs as well, and then save that threshold, and then maybe give this to somebody else with, again, zero code to do this prediction. So let's go through another service on AWS. We also have Quicksite, and so Quicksite, what's great about Quicksite is that it also has this low code, no code feel to it, where you can just upload data sets. And I think I have this data. I have some data that I just downloaded. So I'm going to say a new analysis, new data set, and I'm going to upload a file. Now, also, if I'm working at an existing company, maybe they have the data in Salesforce, or they have it in Spark or Jira or GitHub or something like this. But in my case, I'll just upload the data, go to feature importance, take that data in here, and it will give me a preview that shows me the columns and then what the values are. I go next, and then I visualize. And from here, I could then decide what kind of things I would want to chart. I think in this case, it'll create some kind of a default visualization and show me some interesting metric. There we go. So I have some kind of metrics, and you can play around with coloring and charting and all kinds of things. And again, this gives me automatic insights, and it's something that I could then later share with other people in my company. I could click share, and I could publish a dashboard. Or I also could print this. I could put this into a report. I think I can do I can put this into a PDF and then link it into GitHub or something like that. So what's nice about these BI tools here is that, again, it allows me to just upload the data that I pulled from some other source. And this data came from some other machine learning tool. So I could have many low-code, no-code tools that I combine together. But for fun, let's just maybe even take a picture of this. like this. And I think this one also, you can say duplicate visual. I think there's another way to actually export it as a PDF or something. But in a nutshell, those are some of the high level tools that you can use on AWS. And now let's go to the next section here. So let's go to what's next on our list. So we did Apple, GCP, AWS. Oh yeah, Azure. So let's go to Azure next. What do they have that we can use? Well, if we go to Azure, there are some interesting tools in Azure also that are fairly low code, no code, and in particular, one of the tools that they have that's fairly powerful is off the shelf AutoML, and they also have off the shelf computer vision. But let's look at this machine learning system they have. So if I go to this ML platform, we can see this is Azure Machine Learning Studio. This is an immersive experience for managing end-to-end products. And if I click on this, I get this dashboard that allows me to do a lot of things. And this here is one of the ones that I would maybe want to look at as automated machine learning. And if I wanted to say, okay, I want to do a new automated machine learning run, how would I do this? I could say create data set. And I could again either grab it locally or get it from a data store that I created onto Azure, grab it from web files or from open data sets. Let's first start with this from local files, and I'll just go through here and say this is feature importance. Go through here, and then we'll just call this features or something like that. That looks good. Go to next. And then either I can use this existing data store that I've got set up here, grab this data, which is pretty simple data, and I can say, go to next. It will validate the data. Which hopefully is very quick because it's a small amount of data. And it will show me what's inside, and I'll say, yeah, I do have the headers here, and it will ingest the data for me. There we go, column name, feature importance. I can go to next, and it will also infer the schema as well. So again, I'm not writing any code here. We've got all this information, and I even can profile this. And I could select some kind of a compute cluster to profile it for me. And I go through here and I now have ingested a new data set. And if I click on this here, now I put that data in. I can say I want to do an experiment. And I can say, create a new experiment, and we'll say features, experiment. And then what is it I want to predict? Feature performance, importance. It's kind of a silly example, right? Because I don't have anything. It's not really a data set that I can predict something on, but I can go through here next, and I could even enable deep learning or not. But then all I have to do is say, what is it I'm trying to do? Classification, regression, predict continuous numerical values. So let's select regression, and it'll go through and it'll create a new automated ML run. So in this case, it says, the data should have at least 50 rows for a valid regression or classification task. So this is good. It tells us exactly that we don't have enough data. So what I could do is find some other data set. In fact, I have one. I can go to another project. I think I have it with Social Power NBA. So I have some really good data that I could go to here. And if I say, let's see, NBA players' salary, Let's look at this. Looks pretty good. A lot of good information. Here we have the different players in the NBA, and we can have, what else do we have in here? We have maybe, we could try to predict the amount of money they make. There we go. This is a good one. So I'll just download this file. And I think I can just go to raw and say save as, and just put this on my desktop. Now let's do the same thing. We'll go back to Microsoft Azure, where is Azure? It's here. So I'll close this. So go to Azure and say finish. Okay, great. It didn't like that one. Let's go back and do AutoML run again. So we'll say create a new data set from local file. We'll call this NBA data tabular. This is salary data from the NBA. Go next here. Use this data store. Upload the data set that I just put in here. It will then go as well and inspect the schema. We can see that it's comma delimited. It does have headers, so we can say use headers from the first file. And from here we see the different columns. We have the player name, the position, the age, the minutes, field goals, all kinds of great values to look at. And probably, yeah, let's see if we can predict how much money they make. So we go through here. We have all these different values. These look good. We go to next, and then we can say profile the data as well. Click on create. We're going to now select this NBA data set, create a new experiment. We'll call this NBA salary. And okay, now we can get to the point where it says, okay, well, what do you want to predict? Well, I want to predict the money they make. I want to see how rich they are. Here we go, salary, millions. So can we create a model that will show me what an NBA player will get paid? And then it'll ask me to select a compute cluster. I'll go through here, and then I have to tell it what is this. This is a regression, right? So I know it's going to predict continuous numerical values. A salary is a continuous numerical value. We'll go through here and we'll say finish. And now we're going to go through and it's going to automatically go through and do a bunch of work for me and figure out a way of predicting based on all of those columns that it was given, like social media, the rebounds, the points they scored, what team they were on, all this stuff. It's going to just crunch on that for a while, and it will come back and it will give me this report. So this will take a while, longer probably than we have, I think. So what I'm going to do is I'm going to go to a previous experiment that I ran on a different project, and I will look at a run, and we can see the kind of things that it can do. So if I go to this one here, here's an example of actually the same banking data from before that I was using from AWS. And notice what it shows here is if I go to models, that with AutoML, it will actually go through and run a lot of different models. So it will go through and run voting ensemble, max AB scalar, sparse normalizer. By the way, this is a different problem. It's a classifier, so it's a different machine learning algorithms. We go through here and it just, again, with no code, I click a button, it runs. When it's done, of one of the runs, it said, oh, look, this one took about a minute, and this has the best accuracy. And I can even look at the explanation. And I go through here, and I see the explanation, and I can see that there's top K features right here. And I can see that, oh, look, this is the most important feature for my AutoML. And it turns out that how long the customer is with the bank is the most important feature by double, right? The next important feature would be that whether they're employed, which is intuitive, right? If you're not employed, you're not going to be putting money into the bank. You don't have any money. And so this is super helpful. And I even can see a different view, which is the absolute value view. And this absolute value view shows me both the positive and negative relationship of that feature to the model. So we see that in the cases where they do deposit, the absolute value, the positive part is actually the most extreme. But these other features, if you're not employed, it has a negative. It's more heavily weighted towards saying I won't deposit than if you're employed. It has some impact, right? Positive to the model, but the most positive predictor of whether they would deposit or not would be the duration of employment, right? So again, what's great about these kind of tools is that I don't have to write any code at all. I just click a button, run it. I look at the results, and then if I wanted to as well, I could I don't know, take this as well and put this into my explanation, and I could do high-level machine learning, computer vision, deep learning, and I didn't write any code, right? So we could put this in our modeling section. So I could go here and I say, okay, I created a model that predicts who is a customer of our bank, and I'm going to put this into the model. And so later, when I come up with my report, I can link to this, and I can explain. So even this might be a little too much for a CEO, especially if they're the kind of CEO that we have in America, where they don't read books. I mean, there's a lot of CEOs that do, but the one that's running America, that you have to simplify even more, kind of make it more straightforward. And so the key thing that I would probably put in this report, if we were going to do a report on this, would be some findings would be that our ML models show that, and then you put the two things inside, that length of time as customer is a critical feature in deposits, right? So then maybe even I grab this data and I save it again to GitHub. And I go to business report here. And what I do is I put in this conclusion, and I say that my recommendation here would be that our bank, I'll just say example, right? Say like, so I want to do a very firm conclusion for the CEO and say, just as example to the CEO, example conclusion is our bank needs more revenue. Everybody wants more revenue. To increase revenue, we need to create a special marketing campaign that sends emails to customers that have been with the bank for 5 or more years. and offer them a $50 gift card if they deposit $5,000 into a CD. Right, there we go. So we've got actually a very firm conclusion. This is not ambiguous, right? This is that a executive can look at this and then they say, oh, okay, well that's great. I'll have my team look at your report. But you didn't waste their time by going into the meeting with the CEO and starting with, okay, so look, our absolute value is -2 with duration mean with duration mean imputer. So someone that's a CEO would just say, get out. I don't want to hear about it anymore. Unfortunately, they don't want to know anything about this. They don't want to hear about the data. They don't want to hear about any of this stuff. Now, somebody else on their team may look into this, so you do have to have good results here. But when you're doing a business presentation, you have to focus and make it very compelling in your final conclusion, is to say, our bank needs more revenue. To increase revenue, we need to create a special marketing campaign that sends emails to customers that have been with the bank for 5 years or more and offer them a $50 gift card if they deposit $50 into a CD or $5,000 into a CD. That's it. There's nothing unclear about this, and it only took 2 or 3 sentences, right? So that's really my recommendation as you're thinking about building these reports, not just in these projects, but in general, is to have this kind of a structure. And again, you as I showed here, you don't need any code at all. You can write no code, and you can do advanced machine learning, advanced neural networks, business analytics, and the most important thing though is this conclusion, so that there's a call to action for the people that you're working with, and that if you do this approach, you'll be the person that the executives will bring into their office, and because I've been the person in charge of a company, and I know the details, and I could do this myself. But if somebody starts coming in and they start showing me all this technical stuff, it's like, look, get out. I don't have time for it. I'm busy. Why are you telling me all this stuff? What do I need to do? You need to give them a call to action. This is more likely going to be, now you can't make it up. You can't make up the data, right? That's going to be a problem. So you better have your facts together in your report. But if you're the kind of person that comes in and gives people very concise information with a call to action, you'll probably be one of the most popular people in your company, because you're always going right to the point, giving someone what they need, and you're a very helpful resource for your organization.